All right, so I will start with course agenda from here, which I got it from you. All right, and then quickly I will get into it. So in this demo, I am going to present about a few things like database category, introduction to NoSQL, type of NoSQL databases, challenges with traditional system, and why NoSQL, and then we'll jump into what is MongoDB, introduction to JSON vision, some use cases about MongoDB, and finally environment setup of MongoDB. So those things we are going to cover in this demo, quick demo. All right. So I will start with database category. If you could see here, we have three major category. One is OLTP, second one is OLAP, and third one is NoSQL. So OLTP, we know, we say this is a real-time database. Abbreviation of OLTP is online transactional processing system. And we refer a relational database as well to the same system, where your application will be attached and directly your application will start pushing or perform some transactions right away. So there won't be any delay in between transaction from application to this kind of database. And that's the reason we say real-time database. Now second category comes OLAP, which is called Online Analytical Processing System. This is also called Data Warehouse System as well as Decision Support System. So this is another category, broad category. I am talking about broad category. So what happened with OLTP? Because already your transactions will be pushed or will be happening through other applications. So the load will be high on this OLTP system or real-time system. So let's say if you wanted to perform some kind of analytical activity, reporting activity, or some other kind of activity, this will hamper performance of your OLTP system. So that's the reason another category came into the picture. Or there was a need of another category, which is called DW, or Data Warehouse, or OLAP, or Decision Support System. So that's the reason of evolution or requirement of OLAP system, even though we were already having OLTP system. Now, again, this OLAP, or Data Warehouse System, is not much capable to cater all our today's need. If I'm saying today's need, we'll discuss what is today's need and why there is need of another system. So as there was some different kind of system apart from real-time system, OLTP, so then OLAP came. Again, we saw due to changes in our day-to-day needs or day-to-day requirement, another system is required, which can cater all our requests, which cannot be accomplished either through OLTP or OLAP. And that new category is called NoSQL databases. NoSQL in the sense, we can say no SQL, not only SQL, or new SQL or new generation databases. So we can say this is the third category at high level, and this is the new category, which is called NoSQL. All right. Any question here, Diwakar?
No, go ahead.
All right. So the same thing I was explaining. Let's say if you have your OLTP system, already some applications like banking application, loan app, credit card, insurance, or whatever application is there, if they are already attached with database. Now, on top of this, if you wanted to perform some analytical activity, reporting activity through some tool, these tools will degrade performance of your database because already applications are attached, and these are online real-time applications. So this application will become slow. So that's the reason we don't put all this kind of reporting analytical system directly on OLTP system. What we do is we put all these things into with OLAP system. OLAP in the sense you can say data warehouse system. So let's say if you have various OLTP system here, you can have another kind of system which is called OLAP or DW system, And then you can perform ETL jobs to migrate data from OLTP systems, and then on top of this, you can perform all your reporting or analytical activity on this. So that was the need of data warehousing system. Now, as I said, due to changes in environment or requirement, so again, this guy, OLAP, is not capable to cater all our today's need. So another guy came into the picture, which is called NoSQL database. So, and this is new generation database as well. So what we do is, previously we were migrating data from OLTP to OLAP, and then from there we were doing analytical or reporting activity. But with this new generation databases, what we can do is either we can migrate data from OLTP systems to to NoSQL databases, or just we can have NoSQL database, and then we can attach our applications directly to this NoSQL databases. So eventually you can remove this OLAP as well as OLTP also. In some use cases, I am not saying everywhere, there will be some use cases, particular specific use cases where you can use the same NoSQL database at the place of OLAP as well as OLTP as well. So those things we can do with NoSQL. Now let's quickly understand what is NoSQL. So as I said, it's a new generation database or new category of database which is required to fulfill our today's need. It is non-relational. You will not have joins, but there is a way to perform joins. Even your application can resolve those joins manually. So here we have to lab. There won't be any transactions in this. Transaction support won't be there. It is open source and then horizontally scalable. So if I'm saying horizontally scalable, in the sense you can use your commodity hardware instead of using expensive server class machines. Just you can have normal commodity hardwares and you can run your NoSQL database on that. Distributed architecture. So here this is very, very important. A distributed architecture in the sense you will have multiple machines, multiple storage to have distributed processing as well as distributed storage. So now we'll see in details about distributed architecture and how exactly it works. Schema-less. So this is again very, very important feature of NoSQL. If you talk about relational databases or traditional databases, we will have fixed schema. For example, let's say if you wanted to create an application, so first you have to create the same kind of field inside your database, field or attribute I can say, and then only you can create your application along according to those fields. But here in NoSQL you don't have to bother about your database. Just you have to think about your application, how exactly it should look like, and automatically it will be taken care by database. So for example, let's say if you have to create a 4-field application, 4-field page in your application, then obviously 4-field table you have to create in your database. But here you don't have to worry about those things. As many as field, I mean, this gives you on-fly everything. Even you can increase your number of fields, decrease your number of fields, it doesn't matter, it will take care. Apart from that, it is having ability to manage huge amount of data. If we say huge amount of data, so we are talking in terms of petabyte, exabyte, and so on, which cannot be managed easily through RDBMS or traditional system. Also, NoSQL databases provides easy replication and auto sharding, which was very difficult task in traditional system. So here, once you have done setup, automatically it happens. You don't need to worry about manual configuration and so on. Once you have done, automatically it will take care. We will see in upcoming session replication and sharding. Last but not least it can manage structured, semi-structured and unstructured data, which is really very, very important if we say today's date. So structured data is not growing that much like semi-structured or unstructured data. So traditional systems are having, traditional systems are not having that much capability to manage semi-structured or unstructured data. So again, that's the reason this NoSQL database came into the picture. Any question here, Diwakar?
No, please go ahead. Thank you.
All right. So now let's understand about database category, type of NoSQL databases. So at high level, we understood there are three categories: OLTP, OLAP, and NoSQL. Now let's understand about categories of NoSQL databases. So just to let you know, there are more than 150 NoSQL databases are there in the market. So it's very, very difficult to choose the right NoSQL databases, or which one will be better suited for your use cases. So we have to have understanding about all high-level categories, what all kind of databases is there, and then also we should know what all pros and cons are there for each and every category. So at high level, there are four categories of NoSQL databases is there. Key value store, this is simplest one. Second one is columnar. Third one is document oriented. And fourth category is graph store databases. So this key value store, this will be simple, very, very simple category. You will have one key, and in value you can put all your values. For example, let's say we are talking, let's say if you are designing one schema about a student, university students. So there will be a student ID, and that student ID will have all information along with that ID as a value. So here ID key will be student ID, and values will be like name, email ID, temporary address, permanent address, course, and so on. So everything will come into a single row or tuple, you can say. One will have key, which will give you a unique ID about that particular student, and then all other fields will have information about that student. So that's how it works. Second will be columnar, and in key value, various kind of vendors are there: Memcached, Coherence, Redis, and lots more. Even Oracle, BarclayDB is there, Amazon, DynamoDB is there, and so on. Columnar, same. This is mainly used for analytical activities. If you have millions of rows, billions of rows and millions of columns, then you can go for this, and this gives you facility for fast analytics, fast read and write operations. So every category is having different kind of use cases, by the way. Third category is document-oriented databases, where MongoDB falls under. So you could see here MongoDB, Couchbase, CloudEnt is there. Some more examples are also there, like CouchDB, then TerraStore is there, lots more. Last one is GraphStore, where you will have Neo4j, Oracle NoSQL, Hyper GraphDB, Infinite Graph, Sons. So various examples are there. So these are four high-level categories. So this graph stores we use if we have various kind of connections. If I'm saying kind of connections, so let's say if there are multiple relationships, then we can go with graph stores. We can take one example. Let's say if you have social media connections. So one people will be connected with 200 people, and then all those would be connected with some other 300, 400 people, and so on. So if we wanted to maintain those kind of relationships, we can go with graph store or graph databases. Any question here, Diwakar? Any questions? Now, let me move ahead. So what all challenges was there with RDBMS as we were talking? Let's summarize a few more things here. So vertical scaling, which is very difficult. Vertical scaling means, for example, let's say, if you wanted to increase capacity of your server, so obviously you will add more CPU, you will add more RAM, you will increase the space as well, which is called vertical scaling. If you are trying to improve, capacity of your same machine. So this vertical scaling is very, very expensive. If you talk about a server class family and then their devices, they are very, very costly, and up to certain extent, it cannot be scaled up. There are limitations also. For example, let's say if you have 16 core processor and then you have 1 terabyte RAM, there will be some extent till when you can increase capacity of your RAM as well as processor, but after that it will bottleneck. Then you should have same kind of supporting motherboard and everything. So that is not easy task. So this is first point or first problem with RDBMS. Second, it is not able to manage big data. So if you are saying big data in the sense if data is having at least three property, which is called volume, variety, and velocity. So let's say if your volume of data is very, very high, if rate of data generation is very high, and if you have different kind of data like unstructured, semi-structured, polynomial data. So RDBMS are not designed to cater those kind of requests. But nowadays we need to have, because most of the data which is generated from past 3 years is unstructured data, pictures, videos, images, logs, and so on. So that is another challenge with RDBMS. Third is no native support for semi-structured and unstructured data, which I explained with the previous point. There is no native support of polynomial data. So RDBMS are again not designed to cater polynomial data. So let me explain what is polynomial data. So polynomial data, let's say if you have data of data of data. So for example, let's say there is a parent and then that parent information is having child information, and then that child information is having some other child information, and so on. So if your data is flowing like that in RDBMS, we need to create different tables and then provide and then perform joins to retrieve information out of that, which was very, very tedious as well as expensive task. And that is not something which has been supported natively. So that is another problem. Last but not least, again I can say here, fixed schema. So as I was explaining in previous slide, if you wanted to perform any changes in your application, then first you need to go back to database and change the structure of your table according to that application, which may take 6 months time if we talk about the enterprise level applications. Let's say if you have to change the schema, complete the schema, that may take 6 months time. So that is another biggest challenge. If we talk about the NoSQL database, you don't have to worry here at all. Directly you can start concentrating on your application, and on fly everything will be created. We'll see in details. So let's understand then why NoSQL. So obviously to overcome all issues related with RDBMS or traditional system, there is a need of NoSQL databases. So it is having ability to manage big data. It gives you horizontal scalability, which is just opposite to vertical scalability. So in vertical scalability, you were increasing CPU, RAM, disk, everything to get more performance, more storage, more power. But here, you scale this horizontally. What does that mean? So let's say if you wanted to increase performance of your system, just you need to add one more machine. So that machine will have obviously some RAM, some processing power, and some storage. So that's how you can increase your capacity of your server. So which will give you horizontal scalability. Now another biggest point is you can use your commodity hardwares instead of using expensive hardware, server class. So here you can use commodity hardwares along with this NoSQL database. It is having native support to manage polynomial data, which I was explaining before this. It gives you dynamic schema which facilitate agile development. So this dynamic schema, you don't have to worry at all about the back end, which will give you agile development. Your development time will reduce drastically. It is having ability to manage structured, unstructured, or semi-structured data, which is demand of today's requirement. It can run on commodity hardwares, and it is very simple and easy to manage. So these are some key points why there is need of NoSQL databases. Any question here?
No, thank you.
All right, great. Now let's quickly understand about MongoDB here. So first thing, MongoDB is open source, document-oriented databases, document-oriented NoSQL database, which we saw. There were 4 categories, and MongoDB was falling under document-oriented category. The company who developed MongoDB is Tengen. It gives agile database. It provides high scalability, high performance, and high availability. The best and important part of MongoDB is it leverages in-memory computing. So let's say if you are processing your data, it will cache in RAM and process it, and it will throw the result, which is very, very fast. Also, it provides native replication and it automated for failover. So what happens, you will have a structure in such a way that if one machine goes down, another will become up, and that will start capturing request of your request. As well as, let's say if you wanted to increase capacity, there is something called sharding. You will add a machine and you can get more power, which I was explaining before this. All right. So now let's understand about JSON and BSON here. Why JSON and why BSON? So the first thing is JSON. MongoDB is, displays data in terms of JSON, and internally it stores in the form of BSON. So JSON is called JavaScript Object Notation, and BSON is called binary JSON. So whatever JSON we write, internally it will be converted into BSON, and it will be stored inside the MongoDB database files. So that's the reason it's very important to understand JSON first before jumping to any CRUD operations or inserting data or displaying data. In the sense, let's say if you wanted to perform CRUD operations, create, read, update, or delete, then before that you should have really good understanding of JSON, how exactly it works, how it looks like, what is the benefit, and how can you create a JSON object. Apart from that, what all limitations are there? All right. So first thing is JSON stands for JavaScript notation. It is having very lightweight, so you can transfer from one application to other application, one server to other server, and so on. It is easily readable. Anyone can easily understand what does that mean. Apart from that, if you create any JSON file, it gives you extension with .json. So for example, let's say if you have created product as a file, JSON file, so the extension will be .json, product.json. So that's how it looks like. Now, there are 6 categories of data types related with JSON: number, string, boolean, array, object, and null. So how exactly it works, let me quickly walk you over here. So first thing, JSON object, you will have 2 things. First will be called object and second will be called array. So object will start with curly braces and then it will end with curly braces. So this is the first thing which we should understand about JSON. Now, as I said, you will have 6 kind of data type: number, string, boolean, array, object, and null. So let's quickly understand about object and array, because number, string, boolean, and null, these are simple things. Let me show you. So we'll start with number, how exactly it looks like. So first thing, JSON is nothing but it's a key value pair. There will be key, then column, and then value. Now let's say if you wanted to add one more, again what you will say, key 1, colon, value 2, and then you will have key 3, colon, value 3. So that's how you will start creating your JSON object. Now let's say if you wanted to create one document, you will start with curly braces, you will say name, then here you will say the worker, then comma, and then you will give your email, and then you will say the worker at gmail.com. So this is the way we start creating documents. Now, what is object? So this will be called an object. So let's say if you have various fields. So just I am giving one example to understand. Let's say your document is this much bigger. Here you have some different field. Here you have some different fields. So this will be one object. This is called object. Now, what is array? So array will start with middle bracket and also close with middle bracket. So here you can write like Bangalore, you can say here Hyderabad, and then you can say here Delhi, also you can say here Mumbai. Now this is your array. City is your array, and in this city you are having 4 fields. So that's how we start. This is your object. And then this is array. Now you can combine all these things, object and array, and you can create a very strong or very complex data along with this JSON object. So it starts with number, string, boolean, array, object, and null. So let me show you an example here. So here is the smallest example which I have given. So your JSON object will start with curly braces and with curly braces. Here you can say I have given university number is 1002, which is number or integer data type. Name here I have given as Intellipaat, and it is string. And then address, this is another object which I am creating. So you can embed objects inside objects. So here then I have given permanent address, temporary address, and so on. So that's all about JSON. Now, as I said, a BSON. So BSON is internally stored by MongoDB. So it will look like this. You will have something like this. So whatever you will store your JSON file, internally it will be stored like this. This will be BSON. BSON is nothing but binary representation of your JSON data. So that's all about BSON and JSON. Now let's quickly understand about environment setup of MongoDB.
Okay.
So there are various ways to perform installation or running or setting up your MongoDB database. So first thing, before explaining this installation over here, let me explain. So very few cases will be there where just you will configure one machine. So there is something called replication and sharding, because as we are talking about horizontal scaling and to have distributed processing and distributed storage. So we go for a cluster setup. We create a set of clusters with lots of machines. So here just I am going to initiate or explain how exactly it works with single machine, and then how can we create a cluster, how can we create a replicated cluster, how can we create a sharded cluster with high availability and so on. Alright, so here a few things is there. First, we can start through binaries on Windows, Linux, Mac OS, or wherever, or whatever supported operating system is there with MongoDB. We can configure or we can install MongoDB on Windows, Linux, or Mac OS, whatever supported operating system is there, as a service. Third thing is with config file on Windows and Linux, and last one is, these are the three methods. So the third one is the recommended method, because in production environment, let's say if you wanted to change anything quickly, so just you can edit your configuration file and save it, or it will be applied to the databases. So the third one is the recommended configuration for MongoDB. All right. So you want me to show you installation or running at least, Diwakar?
Yes.
All right. So let me quickly show you. So first thing, you have to go to MongoDB site, mongodb.org, and then you have to download it. You can go to here, downloads, and then according to your OS bit, let's say if you have 32-bit, you can download for 32-bit. If you have 64-bit, you can go for 64-bit. So by the way, already I have downloaded. Let me show you here. So this is the place where, let me clean up everything. Now this, once you will download, you will get, let me go back to my download directory. So once you will download, it will come like okay, the file name will come like this. Okay, now you can change this name and unzip this. You can keep at certain locations. So let me just unzipping this. Okay, all right. I will copy this and I'm going to paste it here. Now I'm going to extract this. So it's extracting here. Alright, so this came here. Now I'm going to just verify whether everything came here or not. Alright, everything is there. So I'm going to rename this. Just I'm going to say here Intellipaat, and then here I'm going to change this name as MongoDB. Now if you see inside that bin folder came and then other 3 files came here. Inside bin you will have various tools. So MongoDB is the processee which is responsible for database. Mongo is a shell. We will discuss in detail, but for just demo purpose I am going to show you how it works. So I will start with this MongoDB. Now I will go to this location here. I will open a command prompt. I am going to that directory. dir, you can see here all tools came here. Now MongoDB is a database. I am going to show you help file, MongoDB-help. So with this you can see what all option you can give if you wanted to use in your while starting or while using this MongoDB. So here you can see DB path. I am going to use here simple things, -hyphen DB path, where I wanted to keep my database files. So this is the location where you can store all your files, or you can give according to your choice. Now some more things is there. Here you can see IP address, log append, authentication. So according to your need you can use that. I'm going to use this, I'm going to use the simplest thing. Just I'm going to use here DB path. So now if you will not give DB path, so what will happen? If you will not give DB path, it will look for the default location. So if you have already if you have created already default location, then you don't have to give DB path. Let me show you. So here clearly it is showing /data/db directory for the data files refers to /data/db. So let's say if you have already created, then it will not ask for DB path. Let me go there and create quickly, and then I will show you how can we change DB path as well. So let me go here. So this is a directory where already I have created. So this is what, guys? /data and /db. So this is just /data. I need to create here another folder which is called db, because this is the default location which MongoDB looks for. /data/db. If you could go here, directly it is saying /data/db. Now, if just I will say MongoDB, we guys, Divakar, we are in that software location where all our processes are residing, like MongoDB. I am going to just say MongoDB. If I will say MongoDB, automatically it will understand that the data file location is in /data/db. It will not ask anything and it will start it. Just you have to allow this. Okay. Once you say allow, automatically these files got created. It means that database got started. It is showing here waiting for connection on port number 27017. Now, you can do one more thing. You can change this data. So before doing that, let me go there and show you whether database is up and running. So this is the location, right? Sorry, not this one. Intellipaat and then MongoDB, then bin. So this is the location where our software is residing. Now, just before some time, we have started MongoDB, which is database. I am going to start here Mongo, which is cell. So if just I will say Mongo, it will connect. It got connected. It's connecting. Let's go here and see the log. It is saying waiting for connection on port 1, so still the connection has not been initiated. So here, actually, it was trying for local host, but if you could see my host name, let me show you. Host name is HP here. So that's the reason it was asking to give me icon host name here. Now you can see show DBS, whatever database is there, local, model 1, model 8, and so on. So that's how you start your MongoDB, and that's how you connect through shell. This is your client. Mongo is your client, and MongoDB is your database. Any question here, Diwakar? Anything?
No, sir.
This is the way, and that's all I have prepared for this demo.